Hi and Assalamualaikum. This video we would like to present our CAD project for subject BMFR 3523. We are from group 35 and this present we cover all the process of drawing, simulation and drafting of a Sprocket hub. This is the content for our presentation. This project is designed to understanding and capability in applying the basic principle of the CAD that is creating 2D sketch, 3D models, surface modeling and CAM operation. This project also is to create a 3D model utilizing the CATIA component design module, develop comprehensive mechanical part drafting and apply CAD principle to create 2D sketches and 3D models. The Sprocket hub is the main part of the moped motorcycle located at the rear wheel behind the sprocket and chain. The first objective for this project is to propose and create a 3D design consists of 5 process and command used to build the component. The second is to simulate and generate G code of the milling machine in CATIA V5. The third is to produce detailed drawing on a product of a mechanical part in 3D modeling. Hello and Assalamualaikum, my name is Tengku Muhammad Ashraf and in this part I will talk about the process of how to draw a Sprocket hub. The first thing is go to the start and go to the mechanical design and select the part design. In here we have a username that we can put. So I put the Sprocket hub as our name for the project and then select OK. So you can see here this is our Sprocket hub that I have been drawing. The first thing that I've done for my drawing is do the sketching of 2 circles using the command for the circle, and I will select the center line here and I will do the two circle, which is the diameter for each of the circle is 70 and another one is 160. After that I will exit the workbench. I will go to the pad, this pad drawing, which is the length is 10 mm, so the thickness of this drawing is 10 mm. So then I select OK. The next part is I will do the second sketch, 80 mm diameter, and then after that we exit the workbench and then we go for the pad, which is I put here. The length of our second pad is 35 mm. The direction is perpendicular with the first pad. For the pocket, I will select one circle, also do by this circle command, and I will select the center line for the circle. The diameter for the third circle is 70 mm, and then I will do the pocket on this command. So here you can see the 10 mm of the depth that I will put on, and then I select OK. And then the next step that I draw is to do the sketch. I will just put the center point here, so you can see here. For this part is I will make a hole through all this part, so you can see as I command this part hole here, which I use up to last for this, so we can go through until the below of this project, and the diameter for this hole is 20 mm. And then I select OK. For this one, I will do the sketch, which consists of 2 circles. One is 10 mm diameter and another one is 20 mm diameter. On this circle, I will also draw a straight line, which is the diameter is 15 mm. So it can be one part I can use for pad. I go to the pad command. I pad this drawing beside the center part. The length of this part that I have been pad is 30 mm. So then I select OK. So I need to do this part all over this center. So I choose the circle pattern, and the command shows that how to do the circular pattern. So I choose the instant is 4, so you can see it's 1 2 3 4 here, and the angular space is 90 degree, and then I select OK. So you can see there are 4 pads that have been circular pattern. And then the next part is to do the edge fillet. Consists on above on the most top of our project, fillet edge from here. Then I put the radius 2 mm on this line along the circle pattern, and then I select click OK. So the fillet is come out just like this on 2 mm radius. So the next thing is do the pocket, which is I put the sketch first on here. So here is next part of our sketching process, which is we do the 15 diameter mm on here, and then we can do for the pocket also here to get a hole, or you can do as usual, which is using the hole. Okay, here you can see this is the diameter 15 have been pocket through all this, so you can see the hole is through this all. The depth of this is 30 mm, and then I select OK. And then after that I have to do circular because I need this one hole to be at 4 of our circle, and then I go to circle pattern, which is I select the instant and angular space, and then the instant is 4 and the angular spacing is 90. So it come out with this another 3 hole from this original 1 hole part, which is the last part. I offset a plane from the center, which is 90 mm to here. Okay, so here you can see from this angle, this is the next drawing that we need to be done to make a slot to go to the through all this part and made at the hole here. So this drawing is I do the rectangular, which is the width of it is 15 and the height of it is 10, and then I set to the slot, and it come up like this of the slot. But I need to this drawing to be for all this around of this project. I need to have it all, so I go to the circular pattern. Here I do the instant and angular spacing. I select for this parameter. The instant is 4, so you can add up if you want more instant, and angular spacing is 90 degree. So this one you can set it up and click OK. So everything will come out as you click the OK. So you can see this is the final part of our project, which is the sprocket hub for the motorcycle. It's quite complex. For the next part, my friend Satival will talk about the process of simulation this project, which is using the milling machine. That's all from me. Thank you.
First of all, in this simulation part, I'm going to explain step by step what we have done to produce this pocket hub. So first of all, click at the part operation.1, double click, and here a menu box will be appear, and in this menu box there will be some information which I already set up previously. So first of all, the name have to set up. I have set up it as a part operation.1, and I have select 5 axis machine.1, and here at the geometry part I have select the part body. Secondly, I have set the rough stock.1, and also I have set one safety plane for this part operation. So click at the OK, and next click at manufacturing program.1, double click. So here it will come down the commentary. Here we can see tool changes I have used for some process. Mainly I have used two process here, which is end mill and drilling. So click OK here, and then double click at the first process, end mill process. So in this first process, end mill process, we have computed some parts, which is pocketing process, profile, and facing, and also pocketing process again. So first I have named the tool as a tool change.7, and here we can see I have named the tool bit as T1 and mill D10. We can run the simulation by clicking there and clicking at the running part here. So I already set up the tool bit. Okay. So click at the pocketing.2, double click. So here we can see, here I have set the primestic machining area 6. This is for offset. Here by clicking the icon we can see here which tool bit we have set for this process, T1 and mill D10. So click OK. Next, this is this step is for do the profile process. Double click. So here we can see to this, previously the tool change and the pocketing all is a setup for do the profile process. So here we can see the tool path style we have choose is zigzag, and the direction of cut is climb. So we can run the simulation by clicking the tool path here. So here just now the selecting tool bit has done the outer end mill process. So click OK, and by clicking next part, profile countering, which will do the profile at the middle there. So this box will appear again. We check for also I have used the same drill bit. So run the simulation. So the middle part also already been milled. Mill process is done. Click OK. Click OK again. So next is the facing. Just now it's a round at the out there. It's not facing all the face at the middle here. So by doing facing, the middle part will be smooth and we will face the middle part. Okay, by double click at the facing process, this menu box will be appear. So I have named that facing.1, and this is the information: machine, direction of cut, climb, and type of counter, circular. Okay, so can run the simulation. Okay, we can see the middle part also be faced. Okay, click OK. Okay, again. So next process will be the pocketing process. Okay, So here we have choose the pocket. I have named this process as pocketing.1. Okay, I run the simulation. Okay, we can see it's already white overall already been faced. Click OK, click OK again. Another pocketing process to the outer layer, to face the outer layer. So the same box will be appear. So for this box I would name that is a pocketing.3. So run simulating. Okay, so here we go. The outer part is been faced. Pocketing process is done. Click OK. OK again. So next process will be the drilling process. So I have to change the drill bit first. So this menu box is appearing and I have named the tool change.8, and here I have named the drill bit T2 spot drill D15. This is because we have changed the drill bit to a small drill bit. Run simulation. So you can see we already changed the small drill bit. Okay, okay. The purpose we have changed the drill bit to small drill bit is to do spot drilling. Okay, which we can see here we need to drill 4 holes here. So first we will do the spot drilling by choosing the small drill bit we already set up. So here spot drilling I have named, and the some of the information here already set up, and we can run the simulation now. Alright. Okay, from this simulation we can notice that there is 4 small hole, that is the spotting process, spotting drill. Okay, okay. So next is again we need to change the tool bit. I've named tool change.10, and I've select the 3T drill D10 as a tool number 3. It's a little bit big tool bit for make this hole 4 holes. Okay, we run to make sure the drill bit is changed. Okay, alright, we can see the drill bit already changed to be drill bit. Right. Okay. So now clicking at drilling D.1. So to do the holing process, to drill until form a hole, we have choose the drill bit. Already choose the big drill bit, big size drill bit. We can run the simulation. Alright, we can notice that the hole is been done. Alright, okay. Okay, as a next step, we need to change again the drill bit. Drill bit, I've named the drill bit tool change 12, and I've select T4 spot drill D15. It's again a small drill bit. Run. Make sure the drill bit have changed. Okay. Alright, we can see here the tool bit has been changed. Okay, click again. So spot drilling .7, I have named that spot drilling .7. Run. Okay, this small drill bit is to make a spot drill at the middle. Click OK. Okay, again. So again need to change the drill bit. I have changed the drill bit. The name is tool change 13. Have select T5 drill D10 and the tool number is 5. I changed the drill bit again to a big drill bit for make this middle hole. Run again simulation. Okay, done. We have changed the drill bit. Okay, again okay. So now by clicking drilling point 3, appear this box again. This is to make a hole, middle hole. Right. Okay, run the simulation. Done. The middle hole also done. And simulation. Okay, again. So next step, next process is end mill process again. Double click. So here the box, tool change 0.9, and we change the tool bit. We select 3T1 end mill D10 again. Okay, run the simulation. Make sure the tool bit has been changed. Okay, the tool bit has been changed. Click OK. Okay. So this end mill process is to done profile countering. Double click the profile countering. Here again we choose tool path style zigzag, and we just now we already select the tool bit, small tool bit. Okay, run simulation. This is to make the outer part, milling the outer part. You can see here we already make the outer part milling. Okay, done. Okay. Okay, again. So next will be again we need to change the tool bit to smaller tool bit to make this overall finish up, to make the circle and this slot here. So I have changed, name the tool change 14, and I have select T6 end mill D10, tool number 6. So run. Make sure the tool bit has been changed. Alright, it's changed. Okay. Okay, again. So by clicking at the profile here, double click. Here it's already showed. Now we're going to do this outer part clearing. Okay, here profile countering .9, and just now we already changed the tool bit. Alright, okay. And here the last process. The last process we already done. simulation part is done. This is the simulation step-by-step process already done. Thank you.
Good day guys, I'm Danish over here. So let me show you how I did this drafting process for my project. First of all, we have to open the 3D drawing. This is the 3D drawing that my friend has already drawn for us, which is a Sprocket hub. From here, we have to press start and we have to select the mechanical design. From mechanical design, we have to choose drafting. There will be a new window, so we have to press on a blank page or empty sheet. And then we have to make sure the format is in A3 and the standard ISO and press OK. So once we press that, we will be presented with this empty sheet. So first of all, we have to do the frontal view or the front view. We have to press this front view on the option, and we have to go back to our 3D drawing. This is our 3D drawing. So we have to press the 3D drawing, and it will be okay. So we have to do the front. So this front view, we can move it wherever we want. So over here, I move it over here, and then we have to do the projection. It's quite easy. Just press projection view, and then this is our top view. The next is our side view. Again, with the projection view, and this is the okay, we have the front view, top view, and the left view or side view in our case. Over here, we have to scale it. So to scale it is quite easy. Right click over here, go to properties. This is our properties. You can give a scaling over here. In my case, mine is 3. And press the line. Oh, I'm sorry. Mine is 1. So this is the scaled view of my project. Next, we'll be doing the section view. To do the section view is quite simple. We have to press on the offset section view, and then we have to do a straight line in our front view. Once that's done, okay, this is our section view, and we can place it wherever you want. So this is the sectional view that we have done. So this is my view. I've already arranged it. So from here, I will have to put the block first and then isometric view. This is how I work. So you press edit first and go for sheet background. Okay, once we are in the sheet background, you have to click on the frame and title block. And there will be a new window that will appear. Over here, I choose for my project the title block sample 2, and I press apply. And OK. I'm not going to show you on how I edited this title block, pressing like the details on the title block, because it will make the video lengthy. So I'll skip this part and I'll straightly go to the working view to add the isometric. So once we are here, we have to do our isometric. To do our isometric, first we have to choose the isometric view option. Once we have selected that, we have to go to our 3D drawing again, and you have to click on the 3D drawing. So you will be presented with this 3D drawing, or the the isometric view. So you have to pull it and arrange it nicely in the block, and then so it will be generating. So this is the basic, or this is how I download my title block. Then I've already edited a few of the information in the block, and I've already added the UTM logo on the top over there, and I've arranged it nicely so that I can present it nicely. So this is how we do the drafting. So this is the fully done drafting that I've done for my project. I've already converted into PDF, so you can see over here. And I've already written or filled in all the information that is needed in the title block. That's all. And thank you. Have a nice day. Conclusion. So the conclusion for our project is, the project was done successfully by applying all the knowledge learned in the class. Next, we were able to create product as well as simulate and produce detailed drawing via the CAD software without facing any major problems. The last one is, we learned the importance of CAD as the CAD/CAM software, as it is used both in designing and manufacturing products. Thank you and have a nice day.